Today, we opened this session with a talk from Dr. Benjamin Halpern. Dr. Halpern's research is at the interface of marine ecology and conservation planning. His PhD is in ecology and evolution and marine biology from the University of California, Santa Barbara. His work has addressed a broad range of questions that span local to global scales, including spatial population dynamics, trophic interactions, and community ecology, and their interface between ecology and human dynamics, all with the ultimate aim of informing and facilitating conservation and resource management efforts in marine ecosystems. Dr. Halpern is currently the director of the National Center for Ecological Analysis and Synthesis in Santa Barbara, and today he's going to discuss priorities for synthesis in ecology and environmental science. Please welcome Dr. Halpern.
Thanks so much, Sparkle. Just gonna share my screen. Can everyone see this, the blue forest?
Looks good.
All right, excellent. Well, thank you for inviting me to join this meeting and give this talk. It's exciting for me to share this work. It actually comes from a workshop we hosted at NC's back in February that brought in folks from around the country and actually around the world, since it ended up being virtual, to help think through what are the priorities for our community in synthesis in the fields of ecology and environmental science. So I want to share with you where we came to, and also share a little bit about the process, how we got there and where we're headed, because it was a bit of an experiment in this COVID world of a virtual workshop, and the way that we came up with the set of recommendations and priorities that I'm going to share with you. So first, a bit about who we are, who we were. It was, as you can see, a little bit more female than male, but about even, mostly from academic world, but we had people from NGOs, from corporations and businesses, from government agencies, multidisciplinary folks, and then a few others. And then mostly from the US. That was by design. It was NSF funded, so that initially we were only going to be able to support people from the US when it was going to be in person. But when we shifted to virtual, we were able to invite people from around the world, which was wonderful and really enriching in the input that we got. And then a bit like our discipline, it was more white than others, but we really made an effort to try to include as many people from across different backgrounds in the workshop and in the conversations. So that's who we were, and I think it's important to know that, because these are the ideas and priorities that emerged from this community. We are, of course, just 120 people from a vast community of folks, but it was deliberately trying to be diverse in who was there to try to pull in a lot of these diverse ideas. So the way it worked is before the workshop, we asked people through online engagement, what are the most pressing questions in ecology and environmental science, and how can synthesis help advance these questions? So we really wanted to not only think about what are important questions in our discipline, but in particular, which ones are synthesis particularly well suited to help address, and what are the challenges and opportunities for doing that? And so we had brainstorming sessions that were virtual that really elicited ideas, and then dove deeper into those topics to try to get the nuance and the details of the types of questions that people were thinking about. And then we had an online forum where people could add questions that hadn't emerged through those sessions, and then upvote the ones that they thought were the most important. So we ended up with 323 questions through that whole process, but clear ones that were emerging, not as consensus. We weren't seeking consensus in this, but just priorities that were emerging as ones that a lot of people, or most people, were highlighting. And then we tried to consolidate and categorize those. And I'm going to talk to each of these briefly to give you a little more texture to what these are. But these are the the 7 topic areas, and then 2 aspects here in red that are about the process of synthesis that emerged as really important discussion points throughout the workshop. And then the last bit of our experiment is a group writing exercise where all 120 plus people are active co-authors in drafting and editing the manuscript that's emerging from this. And so we're in a process of drafting, getting comments, revising, getting comments, and then shortly we'll be able to submit the final paper from that. But it's been a really fascinating experience in an aspect of open science, which is like very, very collaborative writing of the work that came out of the workshop. Okay, so just briefly, I want to give you a little flavor of the 7 priority topics that emerged from the workshop. So the first one, and it was very much a dominant thread through the couple days of the workshop, was questions around how justice, equity, diversity, and inclusion influence our understanding of ecology and environmental science. So this is very much about the topics of our discipline and how synthesis can help address this. So questions like, how are ecological processes affected by equity aspects of resource management? Or do affluence and poverty in human societies have different spatiotemporal impacts on ecosystem services? So it's really trying to understand the coupling of the ecology and these questions of equity and justice that influence not just the way that people are experiencing nature, but our understanding of nature. The second one, which is clearly related, is the connection between human and natural systems. So this has obviously been a dominant theme in ecology and environmental science for the past few decades. So really trying to hone in on aspects that synthesis can help address. So this is things that maybe cross scales or systems or disciplines in order to understand what's going on. It's inherently a synthetic question because you are coupling different disciplines to get this understanding. So this is questions like, do human ecosystem relationships differ between terrestrial and marine systems? And can we characterize the different relationships in a systematic way between them? Or how do we disentangle human and non-human or natural variability impacts on the environment? Or do we come to different understandings of ecological system function with different characterizations of humans' positive and negative roles? So these are many questions that are at the forefront of this topic already, and just highlighting that synthesis has a key place to play in this kind of research and these kinds of questions. Again, these are related, but they're important different flavors of the questions that are being asked. So the third main topic was about applied and use-inspired science. So this is really the intersection of understanding and then the use of that understanding for actions in resource management or socioeconomic dynamics. So again, this is a very common theme in our discipline already, but this led to questions like, how do we understand the balance of mitigation versus adaptation in terms of ecological impacts and human well-being outcomes? Or how are individual species responding to climate change in terms of different traits and consequences for species interactions? Or what are the best nature-based approaches to mitigation? So these are really questions that are about understanding the system, but then how do we use that understanding to take action? And then the next set of topics, the next 4, are also related, but in a I guess I'd say more basic science lens. So this next one is about understanding generality. Are there common principles or universal rules within ecology and environmental science that we can discover? And this is obviously something really fit for synthesis because you're trying to look across systems, across scales, across species, across contexts that help you look for general processes, general rules, common principles that guide ecological processes. So questions that we raised here is like, we often need to have a mechanistic understanding for systems. How far can we get with generalizations based on species traits? Or interestingly, what do we learn from being wrong? So, we do a test of a general rule and it doesn't work. Why? And what does that tell us? And what are promising avenues for including increasing amounts of ecological complexity in predictions? So these are really trying to help think through where and how can we find general rules or common principles. As I said, this is related, but it's obviously different and something that's been at the heart of ecology for probably since the inception of the discipline, is the question around scale. Like, how do processes and understanding work across different scales? So questions like, how can we scale up rapid micro-scale processes that directly affect macro processes? Or how does scale affect the conclusions of ecological studies? How does knowledge of local scale ecology impact our ability to synthesize at larger spatial scales with diverse data? So I'm guessing these sound familiar to you. These are common questions at the heart of understanding scale. And from the very beginning, questions of scale have been ripe for synthesis as a tool to bring to bear to understanding them. The sixth topic is really trying to focus on system design, or the architecture of ecosystems and resilience of that. So this is questions like, how does system integration, or the structure dynamics of the system, inform about its resilience? How can ecosystems repair themselves? And are there early warning signs such as increasing variance that may indicate a lack of resilience? So again, these are questions that have been active in our field. They're not yet resolved, and they're ripe for synthesis as a tool for understanding them. And then the last one is this idea of predictability. Ecology has long worked towards becoming more and more of a predictive science, building off of the original descriptive roots in natural history. And the modern era of computer capability and data availability, and especially open data, is really accelerating our ability to think about ways that we can better predict what's going to happen in the future, especially in the near-term future. So questions like, should we forecast? Can we forecast? And how best can we ethically forecast? Or how much does current state control or constrain the future? And how do we predict rare events? So really trying to hone our ability for ecology and environmental science to be more predictive across scales is at the heart of this theme, and definitely something that is at the heart of what synthesis can tackle. So we went into the workshop with the idea of finding these priority themes, which I just shared with you, but it was clear through the discussions that a major topic of interest was not just the focus of synthesis, but the process, or the way that synthesis is done. And there were two emergent themes that really dominated the discussions and are active across STEM sciences as well, more broadly. And the first is really about expanding participation. How do we make synthesis, or encourage synthesis, or support synthesis to be more inclusive in the types of people and ideas and data that are brought to bear on the questions that we're asking? And in doing so, we are almost certainly going to be asking different types of questions because of that, and gaining new insights. And so it was really an important part of what came out of this, is that we need to be very vigilant on the way that synthesis is being done, not just what synthesis is tackling. And then the second, which is of course related, is really expanding the data and knowledge that is brought to bear. So synthesis is having a rebirth in some ways through the last 5 or 10 years, with the accelerating access to open data, and really large volumes of open data, which are allowing really exciting new types of approaches and questions to be asked. But it is still those kinds of data that are being brought to bear to the questions. And what about the data that are not as open or easily accessible? Or what are about the types of knowledge and information that come from different cultures and understanding that are not deposited in a data repository? How do we start to bring these kinds of data and understanding into synthesis to help us better understand and ask these questions? So a really important topic that emerged from the workshop. And that's what I wanted to share with you. I wanted to leave time for questions. I'm guessing that these topics aren't surprising to you. They, like I said, they came out of a workshop of people like you. Actually, maybe some of you were there, which was wonderful. And I just want to emphasize too that they're not a consensus statement. We weren't seeking everyone confirming that they agreed exactly with this set of topics. It really emerged as a priority set of ideas that emerged from the community that we consolidated and honed into this list. I think they most likely resonate with what you would expect from the community, which is helpful. And then I think, and I hope it really helps motivate the community to continue to push forward on these themes and these processes about how synthesis are done to really help advance our community's research and our community. So with that, I'll end, and I thank you for your attention and your time.
Thanks, Ben. That was a really great talk. If you have any questions, you can go ahead and raise your hand and I'll call on you and unmute you.
Can I just ask a question?
Go ahead,
Hi,
Ben.
I'm Ben Runkel. Ben, thanks for the talk. I'm curious what resources there are from the Synthesis Center for implementing some of these ideas that you've proposed.
At NCEAS or more broadly in our community?
Maybe NCEAS first, but then, yeah, you could think about more broadly. But I guess we might be more familiar with the broader perspective than NCEAS.
Yeah. So a couple things that we have at NCEAS that help enable and facilitate this kind of work. So we have a whole bunch of short courses in our learning hub that help people build the skills to be able to access and use the kind of data that are here. And it's really about open science, team science, collaborative science, and bringing in diverse data and understanding into the research. So those short courses are offered regularly. They're currently virtual, but we're eager to have them back in person. And then occasionally we have open calls for teams, call them working groups, to come together to tackle key questions. Right now, those are primarily done through the LTR network office, which is housed at NCEAS. And so I think about once a year, there's an open call, and that's a great way to engage, to propose a question that sits at the heart of one of these themes or across the themes, and bring it together a team and then tackle it over a 18 to 24 month period. So those are the two main ways to engage. I would say we also play a role in trying to build community across networks. And so I guess this is self-promotional, but I encourage you to follow us. You'll hear about other opportunities or ways to connect to other places that are doing this kind of work. There are other synthesis centers too. So the Powell Center, which is in Fort Collins, Colorado, is another great opportunity, especially for this community, because there's a lot of interest in merging the earth sciences with the ecological sciences. And so they have open calls for working groups through the Powell Center as well. Similar idea of kind of bringing together teams to tackle core questions. So I'd say those are the most salient opportunities. Yeah.
Thanks, Ben. It looks like we have time for another question or two.
Oh dear.
Go ahead, Margaret.
Yeah, except the minute remembered where the little button was, I forgot my question, but I wanted to thank you. It's just a really interesting talk and spurred a lot of thinking and imagination. I'm curious if you all talked about the state of meta-analysis and how that relates to synthesis. And I'm asking maybe from a kind of negative point of view. I have concerns about the relationship between meta-analysis and understanding and knowledge, sort of a hands-off approach. So I'm just curious.
Yeah, it's a great question. We did talk about it some, and of course there are many different tools for doing synthesis, and meta-analysis is one of the early ones, in part because that was the way you could find data, is extracting it from papers that were published and then pulling it together. And the field of meta-analysis has definitely matured over the past 20 or 30 years to address some of the critiques that are raised of the early generations of meta-analysis. It definitely suffers the bias of what gets published, right? So there's been a lot of talk about, well, negative results or uninteresting, quote unquote, uninteresting results, or just information that wouldn't get published in a paper can't be included. And they try to account for that, but there's limits to what can be done.
Yeah.
I think for me, it's thinking about your toolbox. Like it works well for certain things, not everything. And there are other tools and approaches for synthesis, especially in this day and age with analytical compute power and the types of data and this volume of data that are being produced, just open up other ways of doing synthesis that are really exciting as well. So I guess that's what I would say. Like there's definitely, it was discussed, there are limits to it, but I think it still is an important tool to bring to bear at times.
I really like the emphasis on the ecological understanding in what you were talking about. Really
Thanks.
neat, really neat.
So in the interest of time, we have just enough time to thank Dr. Halpern for his great contribution to this session.
Thank you very much for having me. And
Yeah, it's
been
great.
great.